Okay, for this problem, I'd like to do something that you would have come across in your primer. I'm going to repeat the same problem, and in this particular case, I'm going to do it playing with angles. Okay, so it's using rational numbers and angles to solve the problem. So the problem that you had in your primer, we had two pieces of string, and then we had a mass going down like this. Okay, and I've got a force. When we have forces in strings, we call them tensions. And a force going off in this direction, T1, should really tell you it's a vector. Force going off in this direction, T2, and then I could make G into a vector, so everything's nice in vectors. Right. And now, previously in your primer, you saw me solving this using hardcore mathematics. Okay, so we were using irrational numbers, and we solved the problem until we got to the end where we put the numbers into our calculator. Let's solve this playing with angles this time. So let's say that the angle that is being made here is 30 degrees. 30 degrees there and there. Okay. When you've got a diagram like that, you want to get rid of the wall and cut through the string and just look at the forces. So we're doing a free body diagram. Putting a bit of axis there. So my weight is going straight downwards. Haven't told you what it is. Let's make it, oh, I don't know, how much did I weigh at Christmas? So 92 times 98.1. If I take I to be going in this direction, J to be going in this direction, and that will be minus J. So that's what? 92 plus 9.81. Right, good as you can see. So we'll work to 5 sig fig 902.52 newtons. J, strictly speaking, minus 1. Okay. Now for this tension here, so that my T1 is going off in that direction, T2 going off in this direction. Fill it in the diagram a bit more, so I've got 30 degrees going there, 30 degrees going there, and then to the horizontal I'll work out the complementary angle there, so we've got 60 degrees going along the bottom, 60 degrees going along the bottom, and then I'm going to use the same process as before. So first of all, I'll sum up forces in the x direction, taking left to right to be positive, and they should equal 0. My mass shouldn't be going anywhere. So the first one I see is that I need to swing the T1 down to the horizontal, and it's going to be pointing in the opposite direction that I've decided is positive, so it's going to be minus. So I have minus T1. I've swung it through 60 degrees. So cos 60. This one here, I'm going to swing it through 60 degrees. This time it's going to be pointing left to right. So I'll be pointing in a positive direction. So plus T2 cos 60. There's no other forces, so that's 0. Right, well, we can tidy that up and we can see that T1 equals T2. Okay, so no difference to what we had before. I could put my number in cos 60 there, put my number in cos 60, but I know I'm going to get the same result. T1 equals T2. Right, so the next bit of the problem is where it slightly changes if we're playing with angles and rational numbers. So we're going to look at the forces going upwards, Okay, so this time we're going to swing through the 30 degrees. So I have T1 cos 30. Now I'm going to swing through this T2 to go upwards, and I have T2 cos 30. And then the other force I can see is this one going down, which is the weight force, and that weight force is minus 902.52 equals 0. Right, so previously I've worked out that T1 equals T2, so I could replace my T2 with a T1. Therefore, I have 2T1 cos 30. So everything we did previously is the same, really. So 902, but notice I went and straight put in numbers there for the weight, so that was a slight difference. So the answer therefore is going to be T1 equals 902.52 divided by 2 cos 30. So if you're playing with angles, we want to try and keep the cos 30 to the very last step. Alright, and it's at this step that we then get our calculator out and work out what that number is going to be. So 902, I've still got it in my calculator, so divide that by, open a bracket, 2 times cos 30, close my bracket again, and I'm going to get an answer of, well, we'll do 3 sig figs this time, so 5 to 1. And that's newtons. And therefore T2 equals 5 to 1 newtons. So notice there's no irrational numbers there. I've tried to keep my cos to the end when I've put it into my calculator, and that's my solution. So that's how I'm going to solve that problem, avoiding irrational numbers and playing with numbers.